Okay, so here at ATX West, we're talking a little bit about industrial Ethernet. So industrial Ethernet continues to drive a lot of the product development decisions that we make at Applied Motion. Right now, we are set to launch this year new add-on instructions for EthernetIP. This will be a great improvement over our existing add-on instructions and will really help support our compatibility with Rockwell controllers. In addition to that, we're also launching this year a new line of stepper drives for EtherCAT. EtherCAT continues to be a popular networking option for our customers. This is our existing line of step servo drives and motors for EtherCAT. Later this year, we'll be offering a line of open loop stepper drives for cost-sensitive applications using step motors.
Excellent, that's very cool.
We're also excited to be embarking on our first Profinet project this year. We've started collaborating with Siemens, and we will be putting Profinet into some of our drives and integrated motors.
So that's kind of interesting because like the whole move to Ethernet-based protocols is really strong, but you feel that there's value in supporting Profinet and...
Yes, yeah, definitely.
Okay.
They don't have quite the market share here in North America, obviously, that they have in Europe and elsewhere.
Okay.
But as a part of Moon's Industries, we are now a more global company, and so our teams in Asia and Europe would really like to see Profinet. And of course, there is market share here in North America to be had. So.
Yes, and as networked and smart systems continue to grow, we still see Profinet being really relevant, but
absolutely
maybe less growth. But who knows, right?
Yeah. Right. Yeah, it is. They don't have the market share here in North America, but we still think globally it's, of course, a very important network to use.
Excellent. Yeah. Another thing that we're seeing is just more and more simplicity in connectivity in regards to the physical connections and wiring.
Right. So along those lines, we have an integrated product that we've had for a while. It's a closed loop stepper motor, NEMA 11. And one of the things we found was on this very small motor, we have this very small connector. And in that small connector, we have power, I/O, and communications. It's a lot to cram in there. So some of our customers said it's too tough to cram that in there, so we developed a connector module shown here that splits that one connector into three. And it seems like a simple modification, and at its root it really is, but it makes such a difference for our customers because now they have power and I/O on this one connector, and they can break communications into two separate connectors and daisy chain multiple units together. So it makes connecting the motors, multiple motors together, much, much easier. And it's a kind of customization and value add service that we can do for our customers that makes their life much easier.
That's excellent. And hey, while we're holding this, do you want to talk a little bit about the actuation?
Absolutely, thank you. So what we've done is we've taken the standard shaft on our TSM11 step servo integrated motor and we've replaced it with a high precision ball screw. So this is commonly referred to as a nut motor. What differentiates this from other step motor based nut motors on the market is it's fully closed loop. So we get all the benefits of step servo closed loop, higher forces, quieter operation, it runs cooler, it's more efficient, and it has the ball screw on there. So this is a stroke of 66 millimeters. It's a 1 millimeter lead, has a repeatability of 20 micron. We can put pretty much any ball screw or lead screw that we want in here, and it gives a ton of options for our customers that want to do linear motion in a compact footprint.
Excellent. And I know you've mentioned some pump applications possibly.
Yeah. So any type of positioning applications, pump applications, we can do force control with the motor, so lift applications, insertion, assembly applications, all kinds of things that we can do with that in a very compact footprint.
Well, thank you very much, Eric. That was a really good summary.
Thank you. I appreciate it, Lisa.
All right.